Okay, today we're going to start talking about sheet metal and structural repair. And like anything, we're always going to start with just kind of an overview of safety practices with all the things that we're going to be working with. So what we're going to do is we're going to go through all of the tools that are available to use. And that's why we're in the tool room. And we're going to talk about like safety concerns as we go through them. So to get us started, we have the scale. All right, so the scale is once again like kind of a fancy term for a ruler. All right, now there's all different sizes that you're going to use, even though it sounds ridiculous, they have to be calibrated depending on the environment that you're in. Most people don't calibrate the scales that they use. However, if you get into a production environment where they're building things, they will have to be calibrated because you're producing things using the scale you're building things that are brand new, so you have to make sure that the ruler that you're using is actually still accurate. And so every once in a while they'll go and take them and then make sure that there's nothing that's been rubbed off, there's nothing that it's warped or bent or anything else like that, and make sure that it's still good for use. And the way to enforce that is just to have a calibration system. So don't laugh whenever you see a ruler that has to be calibrated. Only real safety concern with that is that they are really, really thin. If you look at them, they're really just pieces of sheet metal itself, so they can cut you. So make sure that you're just cognizant of that as you start to use them. All right, so the next tool that we're going to go over, the next layout tool, these are all layout tools, is the combination square. We went over this in general. The combination square is really, really useful for setting the appropriate angles for cuts and things of that nature. So with the combo square, you want to make sure that you're proficient in its use. It's probably its main safety concern. The reason being is that if you're off a little bit on it, and then as you start to build, you're going to turn around and having to redo work because you didn't know how to use the tool. You made a bunch of cuts based on the tool itself. Now you've just amped up the stress level for the whole project. That leads to all sorts of problems that you wouldn't be otherwise subjected to had you just known how to use a combo square. And if you don't know, ask. One of our core values is humility. Then this reason, if you don't know something, ask. Okay, another one is dividers. Now these come in all kind of shapes and sizes. This just looks like a little regular compass. The idea with these is that you would be able to measure something that you otherwise wouldn't be able to get a scale into, or maybe you don't have the right type of micrometer or what have you. You would be able to figure out how wide or how deep or how skinny something is, and then take it to a scale and lay it up and measure it so that way you know what's right. Now these things are extremely sharp. They're made to be able to get into sheet metal and stay there. In order to do that, you have to have a really fine point on them. So make sure that you keep them out. Don't put these in your pocket or anything. If you sit down, you'll stab yourself in the leg. There's all kinds of problems with that. Okay, another thing that we don't have presently, but does get used in these really big kind of manufacturing environments, are rivet spacers or rivet fans. What they effectively do is you'll set the fan to a certain rivet layout, and we're going to get to rivet layout here in a little bit. So that way you don't have to go through and measure every single rivet to make sure that it's in the right spot. You kind of set the device, lay it up, and then mark the metal based on the device, and then you can go around and drill your holes. Big thing with those is don't pinch your fingers in them. Don't let them get bent or warped because that'll throw the measurement off of it. Other than that, they're a pretty neat tool. They're kind of going away. You don't see them as often as you used to at one point in time. Okay, so just like in carpentry or anything else like that, you're going to need to make marks on material. Like if you do a rivet layup with a rivet fan, you're going to set that rivet fan up and then have to mark where those rivets go. So what do you use? So you can use things like paint pens. These are really good. It's one of my personal favorites for marking on things that otherwise may be difficult to mark on. It's white, so it shows up really good against darker backgrounds. You can use Sharpies, and they have all different types of points that you can turn around and make marks on there. They're also, both of these will clean up with some isopropyl alcohol and a wipe, and they'll just come right up. So it preserves the integrity of your sheet metal that you're marking on. What you don't want to use is a graphite pen. the little mechanical pencil from my desk. You don't want to use any kind of graphite. The reason being is that they've seen over time that the graphite will cause corrosion with the aluminum, and so just steer clear from that. There was a time where that was kind of like the gold standard. People would always go to it. You don't want to do that now. Another one that we don't have because we have other means to marketing is a China marker. It's kind of an art supply type of thing. You'll see that in a lot of different places. They're a marking center core with this kind of paperish material that gets wrapped around there, and you just pull this little white thread and to sharpen it, and it'll come loose. Those are really good for marking on like plexiglass, things like that. That is also something you'll see on a pretty regular basis. So anyways, marking tools. The only real safety concern with those is the graphite. And you want to make sure that whatever you can mark with, you can also take it off, so that way it doesn't mar the surface, or if you make a mistake, you can remove it as needed. Okay, so another tool that you'll end up using a lot are punches. Now there's all different kinds, so let's talk about the different types of punches that you could come across, and then we'll talk about one in particular that you're going to use for sheet metal layup. This is just a regular center punch. There's all different sizes in your toolbox. The main thing, we used actually one of these this morning to get a bolt that was corroded into a strut fairing that we needed to get loose. But you essentially take the punch, you'll set it on whatever you're going to strike, and then you take the hammer and you strike the other end of it. Now, this is probably the first real true blue safety thing that we're going to talk about in this section. But these punches have been known to flake or kind of explode, or like they'll mushroom out over time. You'll get this kind of like mushroom effect of after being struck multiple times, and you can get little shards of metal that'll come off. So you think you're up, especially if you're up close to it and you smack something with it, and one of those shards of metal comes out, that's going to go into your eye, or it's going to fall out the airplane, or it could be any number of things. So one of the key things that you want to do is like look at this punch and make sure that it's in good working condition. If it starts to mushroom or starts to crack or starts to show any sort of wear, just get rid of it. Effectively, all it really is like a little metal bar. They're not really that expensive. And so it does far better to just make sure that you have a good serviceable punch that you're going to use before you actually use it. They also come in all different kinds of a variety. Like here's another one that's almost kind of like more like a chisel. Matter of fact, it's right next to your chisel on there. So if you needed to pry something, which you don't want to pry with your center punch because you will bend it, especially the smaller ones. But you could pry with this one. You can also like really get after different things. I mean, it's almost like it's made for that. These types of punches are for super serious work that's not very precise. You're not trying to like coax something out. You really want to get it out. You also have other ones that have like I said, more of a chisel blade on there. They're used for whenever like brute force is necessary. They're also made of a different type of steel, so they won't break and fall apart. But you still want to follow the same safety rules. If this thing starts to fall apart on you, then you want to just throw it away, get a new one. Now this one is probably one of my favorite aviation tools. It's the center punch. All right, here's the center punch in action. That little that snap that you heard actually made an indentation in the metal of the toolbox. Now, the reason why that's important is because as you start to do your drill rivet holes and so on and so forth, you're going to go through there. You're going to get your spacing. You're going to get your layup right. You're going to mark it all. Then you're going to come back with the center punch and you're going to punch every single one of those marks. Why do you do that? It keeps the drill as you come on top of it. It will keep the drill from walking off on the metal and going somewhere that it's not supposed to. It creates like a little divot for that drill bit to sit in, and it keeps it from sliding out or whatever. This is like an extremely handy tool to go through and punch all the different places that you want to drill. Now, that is what this is for. It's not for driving anything. It's not for prying anything or anything else like that. They're not calibrated, but they have internal mechanism to make that punch work, and you don't want to jeopardize it. So you definitely don't take this one and try to do the job with this one, and absolutely don't make it do the job of this one. So you always want to use the right tool for the right job. The job that the center punch, the automatic center punch does, is to mark sheet metal primarily. I can mark other things as well, but primarily you're using this one to mark sheet metal and nothing more. If you try to use it for other things, you're just going to break it. That's all that's going to end up happening, because they're not really made for the same kind of rough and tumble play that the other two are. Okay, so another one that comes up is the awl. Now there's all different kinds of awls. You'll also hear these described as scribes. There's technically a difference, but they get used for pretty much the same thing. So a scribe is to make a scribe mark to scratch on something. I would recommend trying to stay away from that at all costs. There might be a random situation where you have to scratch into something, and this is the tool for it. But generally speaking, there's no reason why you can't just take a Sharpie and make the marker on it, except for in some random kind of like one-off situations. However, using this as an awl is very useful. It's basically just an alignment tool. So like if you have a piece of sheet metal that you got in the layup and it just doesn't want to line up right very well, you can put this in there and then kind of leverage it up to make the holes line up, so that way you can get screws in. And once you have screws in it and get started, you pull the awl out and it should stay in place, because now something else is holding it in place. This is a very, very useful tool. The safety concerns with it is that they are extremely sharp, because like I said, they're technically a scribe. They're meant to scratch onto metal and parts and paint and things like that. So use this. We talked about scribe marks in whenever we were talking about air data and RVSM, is that the scribe tool, like they'll tell you like, hey, look, if you're trying to remove some sort of like Comp B, Pro Seal, whatever, from your from a crack in the airplane, that say like if it's some sort of like sealant that you're trying to get out of a groove, they'll say do not use this on an RVSM airplane. The reason being is that more than likely not you're gonna kind of like come off of there as you're pulling all that sealant out, and whenever you do, it's going to scratch the skin of the airplane. When it scratches the skin of the airplane, it throws the RVSM off, and then and there's no real indication that like that happened. And so what will end up happening is the pilot will end up flying what they think is correct, but because of that scribe mark, the plane, it thinks it's at a different level, and so like it could run into another level. Okay, so we've talked about marking tools, layup tools. Now let's talk about cutting tools. If we've laid everything up and then we've marked it all out, it's time to start cutting. One of the most kind of arcane ways to cut sheet metal is with a nibbler. If you'll look at this, it just has like a little jaw that comes down and it pinches the metal and cuts it that way. Now, this tool will absolutely just kind of wear on your forearms if you use it. So there are pneumatic and electric versions of it, which if you're going to be cutting a lot of sheet metal, a electric nibbler is actually really, really useful. The main thing to take away is that keep in mind this is made to cut sheet metal, all right, and it does it by pinching it. So don't get your finger caught up inside of this thing, because it will absolutely cut your finger like no big deal. It takes a little bit of effort to do that, but you could think if you were in a tight spot and you're trying to nibble and you get it on your finger. So that's something you need to be very, very cognizant of as you work through using a nibbler. The next one, probably one of the most common ones that you'll see being used out on the hangar floor, is a pneumatic, either an air ratchet or a cutting wheel. This cutting wheel is basically worn down to the nub because we were trying to cut some like really thick aluminum with it the other day, and we just haven't replaced the cutting wheel on it. But this is something that you'll see like every sheet metal guy has one of these in their toolbox, and because it works really, really well. And so there are grinding discs that you'll grind things off with, and there are cutting wheels. So you definitely want, if you're going to cut, you want to use a cutting wheel because of the way that the wheel's made. If you try to cut with a grinding wheel, it'll cut it, but it's going to eat the grinding wheel up. If you the other way around is not that much more effective. But anyways, so here these air ratchets and these pneumatic cutting wheels. They come in a variety of different kind of shapes and sizes, and over the time, if you're a sheet metal guy, you'll amass all the different types, angles and all kinds of things that you need for any particular job. And that's one of the cool things about if you're a tool guy, sheet metal is for you, because there's definitely like all kinds of weirdo, wacko tools that are out there for these really specific types of applications. But anyway, so there's those two. Let's talk about some more. Okay, so those devices are really good for making small cuts, but what happens if you have to cut like something really, really heavy, or you have to cut a really long ways? We use bandsaws for that. Now you can get them set up in multiple ways. This is a handheld one, so it's just simply easier on the school to transport and move it around. However, if you have an established shop and you're going to be doing a lot of sheet metal cutting, highly recommend just a stationary bandsaw, so that way you can just take your sheet metal and go right up to it. Now, that's only for like cutting like really, really big things, and you can still take this one and put it into a vise, and effectively you have the same thing, but it's not really the way that it's recommended to be used. So you want to try to avoid, you try to use things the way they're meant to be used all the time. Now, there's no real limit to the different types of cutting devices that are out there. The real thing is just what do you have available to you? Do you have a cat saw? Do you have a circular saw? Do you have a reciprocating saw? All of these are things that you could potentially use to cut something on or off an aircraft. Now, the main thing is that there's a couple of things with any type of saw that you use. You always want to cut away from yourself. So if you have think about a circular saw, you want to turn the blade on and go away from you. So that way, if you lose control of it, you're not like coming at yourself and you're like and have to deal with a saw blade coming at you. You always want to wear all your PPE, so all your personal protective equipment. And that's something that we'll hammer during the risk mitigation portion of class, and then out on the hangar floor. You always want to keep your eyes, ears, and any exposed skin safe from the device that you're cutting and the things that you're cutting. Because a lot of times, a lot of cuts that happen are not from actual cutting devices. It's from the sharp edges left by those cutting devices. So you always want to be really cognizant of that. And we're going to get into what like deburring and sanding looks like in that environment. Yeah, but so always, anytime that you're cutting anything, safety first is the way that you want to focus it. Okay, so now we're going to talk about some other shop tools. Now, every shop is different, and not every shop has the same tools. And so you'll just have to kind of figure out what your shop has that you eventually end up working at, learn how to use those tools and use them well. And usually there's some old guy that's been doing it for 40 years that will show you how to do it. In our shop, we're going to start with the shear. Now, the shear allows you to cut a large amount of sheet metal very easily. It's literally just like a big scissors. If you ever use one of those big cutting boards for paper at school, it's kind of the same thing, but for sheet metal. All you do is you slide the sheet metal into the table here, and then once you have it at the right length, you'll step on the bar, and it'll cut the metal right off. You let it down, and it'll rebound that way. Now, the things that you need to keep in mind when using the shear is that it is going to cut anything that's on the other side of that. So make sure that if there's anybody around you and yourself, your hands are free and clear of that area. Always wear your eye pro. Make sure that whenever you decide you're going to step on that thing and cut the metal, then you're ready to cut, because it's whatever's on the other side of it is coming off. This is like a very, very heavy duty set of scissors that you want to make sure that you don't get crossways with, because it'll absolutely bite you. And something you're gonna have to do on a pretty regular basis is finish different types of metal. So or deburr different types of metal. So if you take a piece of aluminum and you cut off a piece of it, one of the best ways to kind of deburr and smooth it out is actually with a grinder. You take a grinder for steel. They have a certain wheel for it. You can also put wire wheels on there to get different finishes. One of the best ones that we've recently learned about is a Scotch-Brite wheel. You take Scotch-Brite, just like your Scotch-Brite pads that you would take finishes off of things with. Instead of it's a wheel, you put it on the wire wheel, and it will grind aluminum at the right rate to let you make a nice controlled cut through that really soft metal. And so you can put a Scotch-Brite wheel on that thing and clean up just about any sort of sheet metal that you can come up with. Another one to keep in mind is the belt sander. Belt sanders used all the time especially in general aviation to clean up different parts and pieces, any sort of sheet metal that you might end up having to cut or form. The belt grinder works extremely well for. This one has a disc grinder on the side. You can do the same thing. You put your sheet metal up there and just go touch the disc, and it'll grind it on down. A little bit more aggressive than the Scotch-Brite will. So anytime with aggression, you get more speed, but you lose control. And that's it. Now, for safety concerns with either one of those, it's very much just like cutting. You want to make sure that you have like your eyes and ears protected with PPE, and make sure that like anything that you touch to it, you want to cut. Don't put your finger in there because it'll take the hide off your finger. These aren't nearly as dramatic as like the shear or the bandsaw or anything else like that. They're going to be a lot more gentle. They're for more precision type work, but they'll still hurt you, and so you want to be conscious of that. Another thing, since these are rotary and they're always moving, if that metal that's in your hand catches, it's going to want to jerk it out of your hand and either throw it off somewhere or it could cut into you. So you want to make sure that like you think through that possibility that if this metal gets away from me, what am I going to do? If you're using a belt sander and the belt is coming down this way and you lose control of the metal, you can just let go and it should be okay. If you're using a grinder, let's say like you're using a grinder over here, and you're putting a piece of metal to it, and it's going to want to grab it and throw it somewhere, you make sure that you stay on the opposite side of it, so that way if it gets away from you, it goes away. Same thing with the disc grinder. You always have to be outthinking the machine that you're working on, and like pilots have a term where they'll say like don't get behind the airplane. Well, that's true with everything else. Don't get behind your car. Don't get behind the tool that you're working with. It's a machine. It's just going to do whatever it is that you're telling it to do, and like you have to think through like what happens if everything goes wrong. Where am I going to be at? Where's everybody else going to be at? And what do I need to do to make sure that I'm safe? Okay, so another tool that you'll end up using to cut, even though what we've seen before is all the shop level tools that are going to make big cuts, that like there's not one of these for every mechanic working there, there's one for the entire shop, and it's used occasionally. Things like aviation snips are going to be used on a pretty regular basis. And these work just like scissors, that you're gonna want to make sure that like you keep your fingers clear or anything else. But they're mainly for making small cuts, making like trying to form small parts of sheet metal. They come in 3 different varieties that are color coded. They're green, yellow, and red. Yellow being your straight, red being the right-handed orientation, green being the left-handed orientation. So they kind of want to go in those directions. The reason why that's important is that if you want to cut a circular piece to the right, you're going to want the red snip because it's already kind of inclined to go that way. If you want to cut something straight, yellow, left, green. Pretty straightforward, pretty simple. Now these they're called aviation snips because they originated in aviation. At one point in time, that was the way that all the airplanes were built, that they would just cut through large amounts of sheet metal. So those guys probably had like massive forearms from just working those shears or their snips on a regular basis. Nowadays, they're just kind of for trim work. We have better tools that are far better to work with than snips. But either way, safety concerns with these is just like cutting any other type of cutting thing. Eyes and ears, you don't really have to worry about the ears part of it with the snips. But make sure that your hands are clear and you're cutting what you want to cut. And always remember that anything that you cut basically becomes a knife blade until you deburr it and sand it out, so that way it takes the edge off. Okay, another older style tool, but definitely used still commonly for precision things and making little adjustments onto parts and pieces of airplanes, is the file. Now this is a crosshatch file, like where the grooves of the file on the face. This is the face, this is the tang. The grooves of the file are done both ways, so no matter which way you go, it's cutting, so that way you can make a lot of progress really fast, where you can sit there and go back and forth, back and forth, back and forth, back and forth, and it's going to cut on both strokes. So that's for if you want to file something down or cut something out of sheet metal. It allows for a certain level of precision because it's so laborious to file anything with to cut anything with a file. So you remember, there's always a trade-off between precision and speed. If you want to go really fast, it's not going to be very precise. If you want to be really precise, it's not going to be really fast. The file is definitely a super precise, but very slow method of reducing metal. Other ones, you have the little half round file. This one is also etched so that way the teeth cut both ways. And then you have the rat tail file. Now, these I would encourage you just to play with them. There are certain applications where you can say you could use a file for fill in the blank, but really the file is there as kind of a general all-around hand tool for different applications. If you need to shape a piece of sheet metal, this will do the same thing that the grinders will do. It'll just do it really slow and a little bit more precise because you're in control of the speed as opposed to surrendering that control to a machine. But however, there's a lot of things that there could be some sort of damage that you need to try to you try to fix something, and maybe there's like a ding or a burr, and you need to clean up that metal. This could be a device to use it. The most common thing that you will actually end up using it for is dressing props. And we haven't got to props yet, so this is a little bit advanced. But when props get dinged or nicked, you need to go in there and try to smooth them out at every annual inspection. And so what you'll do is you'll take the file. There's all kinds of different techniques. So one thing that you want to do is just kind of like develop your skill set for it. But you can turn around and file down the prop so that way it's smooth, and then you can use your different levels of files to make more gradual increments from the very, very coarse, try to get the nick to be nice and straight, all the way to the very, very fine elements, and try to make it nice and smooth and be as precise as you possibly can. Another thing to remember with files is that you're going to, from a safety standpoint, you're creating little shards of metal. Always use your gloves, if you like little mechanics gloves, to keep that metal off your skin for a couple of reasons. One, there's a chance, especially depending on the hardness of the metal that you're working, it'll create small shards and get in your skin, and it's very, very irritating. It's not something you're going to end up going to the hospital about, but it's something that you're going to wish that you didn't have. I mean, even handling this one with chunks of metal on, there's little flakes of metal on my skin. I'm hoping don't end up in my skin. The other one is that we're working with aluminum. Aluminum has known to be a carcinogen if you're around aluminum dust, or you get it in your skin or anything else like that. So you want to try to stay away from that as much as you possibly can. Use your gloves. If you're going to be doing a lot of it, it's going to kick a lot of dust up. Use a respirator, or at least some sort of dust mask to try to keep it out of your lungs. If you're going to be working in a factory or a place where this stuff is happening on a regular basis, like an avionics shop where they're cutting panels on a regular basis, that's something to keep in mind. Nowadays, modern CNC machines use water to keep the dust and stuff down, and to cool the piece off so it doesn't warp or anything. That helps a lot. But if you're not able to do that, then that's something that you want to keep in mind. Okay, so another one we want to talk about is the die grinder. This is just a little air ratchet. We don't have the head installed in there right now, but you would be able to grind anything down. This is a way to do it. Same thing goes as safety rules, eyes, ears, and hands. The only time you don't want to use gloves and doing something like this is whenever you're drilling, because you don't want the glove to get caught into the drill bit and pull you into it, which happens from time to time. So always remember the die grinder. These air ratchets, they can be used for a lot of different things. Grinding is just one of those things. So it's a very handy tool to keep in your toolbox that you can use for all sorts of things. Another one to clean up holes that after they've been drilled is a deburring tool. These are actually pretty cool. Now all they really are is kind of like a piece of metal that has been filed down to a razor blade, and has a little knob on the end. You stick it inside of the hole, and you're gonna just do a circular motion, and what it does is it rakes that sharpened edge over the hole, and it shaves off any of the small pieces of aluminum that might have flaked off during production, and it allows you to have a hole that's not going to necessarily catch your thumb or anything else like that. And you'll need that to be done before you go into other things like dimpling the hole or anything else like that, because if you have a burr, it could potentially result in a crack, and then the whole part's basically ruined and you have to redo it. Okay, while we're on drills, we're going to talk about pneumatic drills. there's a lot of different types of drills that are out there. They come at different angles, different speeds for how fast they'll turn at max RPM. You can get electric drills, just like Milwaukee drills from Home Depot or Lowe's, and the pneumatic drills. Obviously, the electric ones have the advantage of being portable and not having an air hose pulled behind you. The pneumatic ones generally will perform better and longer, so it depends on what you're doing. If you're doing a lot of drilling, then pneumatic drill is probably actually the way to go. If you're just doing it occasionally and you might need some versatility in it, to say like running screws and things like that, then obviously your electric drill is probably better for you. Now, that being said, there's some universal drill rules that you want to follow. First off, use your what you will call the Boeing finger. So like Boeing drills a lot of holes, so they'll tell their new technicians that show up that are going to be working on any sort of drilling is to point down the drill with your finger at the metal that you're doing. The reason being is that will help you naturally line it up and keep it straight. Because you could hold it like this, and your natural inclination is to get the hole off kilter. So instead of drilling straight through, you drill at an angle. So always use your Boeing finger. And then this particular drill is set up, and a lot of drills are set up this way with this knob on the back to sit in your hand just perfectly, so that way it helps encourage that really precise drilling. Now, another thing to take about is that, like, notice that my hand is not gloved. You do not want to wear gloves while drilling. The reason being is that, like, if you get down into it and your glove gets hung up in that drill is going to want to pull your finger into it. And there's been many mechanics that have damaged their hands pretty severely from that, especially when you get to the bigger and bigger hole sizes. Small drills, you don't really have to worry about it as much, but like, it can absolutely jack you up if you do that. So don't wear, the only time you don't wear your gloves whenever you're handling sheet metal is whenever you're drilling holes. Keep your gloves off, so that way if there's something happens, you sacrifice the tip of your finger rather than like your whole hand. But yeah, so those are drills. You're going to drill a lot in your career. Even it doesn't matter like where you go. The only guy that probably doesn't ever drill anything is maybe the guy who only does engine services or 100 hours on like turbine engines and things like that. Even then, there's probably occasions where a drill shows up. If you're doing sheet metal, this is half your world. You're just punching holes on a regular basis. If you're doing avionics, you're going to be drilling a lot because you're having to usually modify aircraft to meet the demands of the latest and greatest technology, and you do that through mounting a lot of new wire runs, all kinds of stuff. So get comfortable with drilling. It's actually a lot of fun. You can turn around and create a lot of things if you master these skill sets pretty well. Okay, so another type of shop tool that we'll end up using that's also a drill is a drill press. Now, what's a drill press? A drill press is a standalone machine that's made for drilling holes of like a very large caliber. It takes a lot of effort to get through there. For instance, today we were drilling through 1/2-inch plated steel for engine mounts. So you would put your drill bit in here, just like a regular drill. You turn it on, it spins, and you just press it down into whatever it is you're going to want to drill. Now, this is one where absolutely do not use your gloves, keep your hands away, but have your safety glasses on, your earplugs in, because these things will get loud, especially as you start to cut in metal. It'll start to whine and make all kinds of noise, and you don't want to, especially inside of this room that we keep it in, it'll echo and be extremely loud, and you only have one set of ears. So, drill press, enjoy. Just kind of actually, we don't do that. Okay, so now let's talk about drill bits. Now there are a sea of different types of drill bits that are out there. Obviously, different sizes. This is a 21 that you'll need to use. You need to match up to the different types of rivets that you're going to be drilling here in class, and any other type of reason that you might have to drill a hole. Now, most of the time, if you're installing an STC or something like that, the engineering that comes with it will simply say drill a hole of such and such a size, and you'll just go to your drill case, get those things out, and say like, this is the 3/8 drill bit for a 3/8 hole, and you find a spot, center punch it or automatic punch it, so that way there's a little dimple there where the drill bit won't wander around. Stick it in there, drill it, and like that's all there is to it. Sometimes, however, you might have to kind of infer what size drill bit you need. And the best way to do that I've found is just simply take your drill bit and the hardware that you're drilling a hole for, and see if you can match them up on the same size. Because what you don't want to do is under drill, because it means you just have to drill it again. You have to step it up, which you can do that, and we're going to show you a step up device here in just a second. But if it's too big, then you've just potentially ruined a piece of sheet metal that you have to throw out, or you've created a hole in the aircraft that now you're going to have to get, you're going to have to then talk to the FAA about and say, hey, look, we screwed this up. We need approved data to say that we could use a bigger size or what have you, depending on what the application is and what the scenario is. If you're inside of an MRO or a company that has engineering staff like a DER, they might be able to help you out with that. But generally speaking, for your GA applications, you're going to out in the world by yourself, and so you don't want to have to talk to the FAA more than you want to. So do things right the first time with the approved data that they have for you, and you're good to go. Safety bits with drill bits is you don't want to, these things will break, and they it's just a matter of fact. It's not, I'm saying it could break, they will break. You don't want to side load them at all. They'll snap, especially for the ones that are kind of geared towards cutting into metal. Because whenever they have to make them extra hard, and then whenever you get more hardness, you get more brittleness, and then a side load is a good way to snap it, especially if it's like halfway into a hole that hasn't gone through yet and you're side loading it. Know the reason to use your finger to keep that drill bit straight as you're going down, and not to lean one way or the other, because that will break. If it breaks, that's not good for anything involved. You're going to have a broken drill bit that's at a high RPM that goes into the metal or into your skin or into something else. You have another piece that could fracture and shard and go all over the place. You don't want that either. So make sure that you use drill bits that are sharp, that are new. There's a reason why there's a package of these. These are consumable materials. And once you go through the metal, inspect your drill bit, make sure that there's no damage to the drill bit itself, and keep it going. If it starts to wear, or you start noticing that it's taking a long time, just throw that drill bit away and get a new one, because you're going to need to keep it sharp for it to cut correctly. Whenever you have a dull drill bit, you increase dramatically the chances that something could potentially happen and harm you or somebody else around you, and you absolutely will cause damage to the aircraft, because instead of cutting the metal the way it's supposed to cut, it's going to grind it down, and whenever you get that kind of grinding action, you have an increase in heat, and then that heat is not good for anything, almost never, unless you're intentionally heat treating something. So keep your drill bits sharp and make sure you don't side load them. Use your Boeing finger, and all should be well. One type of drill bit that you'll see in aviation a lot that you generally don't see outside in the wide world is countersink drill bits. This is what they look like. They're made to create a hole and then widen that hole up so that way a countersunk screw or rivet can fit in there, so it's a nice flush mount. Why do you want counter sinking done with screws or rivets? Two reasons. One, you want to have a flush mount, like something up, to push up against it, because keep in mind, aircraft space is limited, so you don't have a whole lot of giving away. Whereas on a car, you might be able to say okay, well, the head of this screw is an eighth of an inch sticking out. We have a car that it's not really constrained by just a whole lot. Weight's not a big factor. The space isn't a big factor. We can get by with it. But on an airplane, you need to keep it small, you need to keep it light. So countersinking allows you to make those little adjustments on screw placement that adds up to be a big thing later on. So countersunk drill bits. Okay, so like everything, there's lubrication that comes with drill bits. If you're going to be drilling a lot of holes, Bolube is a type of dry lubricant that will allow the drill bit not to get so hot and be able to pass through the metal with less resistance. It's super handy to have if you're going to be doing a lot of that type of work. Bolube is kind of a staple for your kit builders, your GA guys. What you want to do is just take a little bit, it goes a long way, take it, dab your drill bit in there, and then go to town, and it'll make for a easier time on you and a cleaner cut. Bolube's just one type. There's other brands that are out there. It's just what we have. You always lubricate your drill bit. Okay, another type of drill bit that is useful to have on hand and know how to use is a step-up drill bit. If If you'll notice on here, it's probably too small for the camera to see, but there's different hole sizes. So let's say you wanted to drill a 11/16 hole. That's a big drill bit that you need. What you'll do is you'll start off with the drill bit, you'll cut down, and you'll just go all the way up to the graduation for 11/16. Once it's all the way through, then you can finish out the rest of the hole with an 11/16 drill bit if you have one, and that's how it works. So it's a super useful little tool that every sheet metal dude should have in his toolbox. Now there's a sea of other types of devices like this bushing guide that allows you to put the guide on top of a piece of sheet metal and then set your drill on top of it, and it keeps the hole straight from going in. There's extensions, there's even snake extensions that allow you to drill at bizarre angles. There's reamers to help ream out holes. There's all manner of tools out there when it comes to making holes, drilling holes, to help you become a more effective sheet metal mechanic, building an aircraft from just regular rolling stock to all of a sudden, boom, a fuselage. The best thing to do is to just kind of keep abreast and always ask if you see somebody else, working on an airplane that has something unique. Ask them about it. Stay on top of like all the different catalogs and kind of like learn it as you go what works for you and what works for your particular situation. On the terms of safety, to kind of conclude up this safety bit, always be cognizant of what's going on around you and in your hands. Don't allow yourself to become distracted. Always think about the dirty dozen and how they apply to your in particular situation. Most accidents these days with aviation maintenance, it boils down to a human factor. It's not that something failed or anything else like that. A lot of those problems were engineered out a while ago. All the problems that you see now are because somebody wasn't paying attention primarily. Somebody got rushed. There was an argument. Somebody wasn't really thinking about what they were doing as they're working. They didn't get enough sleep last night or whatever the thing is. Now you can put all the PPE in the world on all the people and have as many safety meetings and like have all these processes and procedures. But one thing you cannot control is the human element. You can't control like what somebody else's girlfriend says to them the night before that has them all distracted when they show up to work and you put a drill in their hands. So always be checking in with yourself and your buddy and make sure everything is copacetic before you see an accident occurs, and make sure that they're doing okay. The more that we can kind of watch out for each other, the safer environment we can create.